Have you ever pondered why Venus is often referred to as Earth's twin? This celestial neighbor of ours has been a part of human knowledge since time immemorial. However, it was in the year 1610 when the illustrious Galileo Galilei first observed Venus through his telescope, marking a breakthrough in our understanding of the cosmos. Venus, the second planet from the Sun, shares a striking resemblance to our home planet in terms of size and mass. Just imagine a globe with a diameter of approximately 12,000 kilometers, and you've got a pretty accurate image of Venus. But don't let these similarities fool you. While Venus might appear to be a mirror image of Earth from a distance, it's a whole different story up close. The atmosphere of Venus is predominantly carbon dioxide, a stark contrast to the nitrogen and oxygen-rich air we breathe. The surface? It's scorching, with temperatures reaching up to 462 degrees Celsius. Despite its similarities to Earth, Venus harbors a very different atmosphere and surface conditions. Let's dive deeper into the characteristics of Venus. This celestial body, second in line from the Sun, is often likened to our home planet due to its comparable size and mass. Boasting a diameter of over 12,000 kilometers, Venus is no small spectacle in our cosmic neighborhood. But let's not forget, it's not just about size. Mass plays a crucial role in the grand scheme of things, and Venus tips the cosmic scales at approximately 4.867 times 10 to the power of 24 kilograms. This mass, combined with its proximity to the Sun, influences the planet's gravitational pull and its overall environment. Speaking of environment, Venus is shrouded in an atmosphere that is vastly different from Earth's. Dominated by carbon dioxide, this thick atmosphere traps heat, creating a greenhouse effect that sends surface temperatures soaring to a scorching 462 degrees Celsius. A temperature so extreme it surpasses even that of Mercury, the planet closest to the Sun. Now, if we were to take a stroll on the surface of Venus, a feat currently impossible due to the harsh conditions, we'd find ourselves amidst a dramatic and diverse landscape. The terrain is hot and dry, a stark contrast to our blue and green Earth. The surface is dotted with towering volcanoes, majestic mountains, and deep craters, painting a picture of a world both alien and awe-inspiring. These features, however, are not just for show. They provide invaluable information about the planet's geological activity and history, and hold the key to understanding Venus's evolution and its stark contrast to Earth. These unique characteristics make Venus an intriguing planet to study. From its carbon dioxide-rich atmosphere to its volcano-studded surface, Venus is a world of extremes, a testament to the diverse range of environments that exist within our solar system. The exploration of Venus began with the first spacecraft visit in 1961. This marked a significant milestone in our journey to the stars. The honor of the initial visit went to the Soviet Venera 1. This brave little spacecraft paved the way for future missions, though it may have been a bit ahead of its time. Unfortunately, it lost contact with Earth before it could relay information about the planet. But this initial setback didn't deter our curiosity. The exploration of Venus continued, with subsequent missions each contributing a piece to the puzzle that is our celestial neighbor. For instance, in the late 60s and early 70s, the Venera missions gave us our first glimpse of Venus's surface. They revealed a world of extreme temperatures, reaching up to 462 degrees Celsius, with a surface marked by volcanoes, mountains, and craters. The 80s saw the arrival of the Venera 13 and 14, which sent back the first color images of the Venusian surface. They showed us a world of yellowish-brown rocks, a stark contrast to the blue and green hues of our home planet. In the 90s, NASA's Magellan spacecraft used radar to map out 98% of Venus's surface. The data it collected gave us a deeper understanding of the planet's geological history, revealing evidence of widespread volcanic activity and even signs of tectonic movement. In the 21st century, the European Space Agency's Venus Express orbiter spent 8 years studying Venus's atmosphere and weather patterns. It confirmed the presence of lightning and discovered a strange double vortex at the planet's south pole. Each mission, each spacecraft, each piece of technology we've sent to Venus has taught us something new. They've shown us a planet that, while similar to Earth in size and mass, is a world apart in terms of its environment and climate. Over the decades, these missions have unveiled a complex and fascinating world. A world of fiery temperatures, crushing atmospheric pressure, and sulfuric acid clouds. A world that continues to captivate us, to draw us in with its mysteries, and to remind us of the boundless wonders that lie beyond our own little corner of the universe. The exploration of Venus continues today with more advanced missions. The new era of Venus exploration is marked by a slew of ambitious missions, each one aimed at unraveling the enigmas of our neighboring planet. One of the key players in this exploration is the European Space Agency with their mission, Envision. This mission aims to study Venus from orbit, focusing on its geological activity and the potential for Venus to have plate tectonics much like Earth. Envision is equipped with state-of-the-art radar to penetrate the thick Venusian atmosphere and map the surface in unprecedented detail. The mission is also set to investigate the interaction between the planet's dense atmosphere and its geology. On the other side of the globe, the Russian Space Agency is planning to revisit Venus with their Venera D mission. This mission is a nod to the Soviet Union's historic Venera program, which made the first successful landing on Venus back in the 1960s. The Venera D mission plans to send both an orbiter and a lander to Venus, aiming to study the Venusian atmosphere's chemical composition and the planet's surface conditions. Both Envision and Venera D are not just missions of exploration, but also of understanding. They aim to answer fundamental questions about Venus. How did it evolve to become so different from Earth, despite their similar sizes and proximity to the Sun? What can Venus teach us about the life cycle of planets, including our own Earth? These missions will hopefully shed more light on the mysteries of Venus. The more we discover, the more we can comprehend the universe we live in, and perhaps find answers to some of the most pressing questions about our existence and our place in this vast cosmic arena. Despite its harsh conditions, why is Venus still an important target for scientific study, you may wonder? Well, let's delve into that. Firstly, Venus is often referred to as Earth's twin, and for good reason. It shares a similar size and mass with our home planet. Studying Venus, therefore, allows us to conduct a fascinating comparative analysis. By understanding the atmospheric, geological, and climatic conditions on Venus, we can gain valuable insights into the Earth's own environment and potential future scenarios. For instance, the high carbon dioxide content and thick atmosphere of Venus result in a greenhouse effect on steroids, leading to its scorching surface temperatures. This could serve as a stark warning for Earth, illustrating the potential consequences of unchecked carbon emissions and global warming. Secondly, Venus's geological features, such as its volcanoes, mountains, and craters, are subjects of intense study. These features could provide clues about the planet's history, including its formation and evolution. Understanding these aspects could help us piece together the puzzle of how planetary systems develop and change over time. Moreover, the quest for life in our universe is a driving force behind space exploration. While Venus's current conditions are far from hospitable, scientists are intrigued by the potential for finding signs of past life or conditions that may have once supported life. For instance, some theories propose that Venus could have had a more Earth-like environment billions of years ago, possibly even with liquid water on its surface. Lastly, studying Venus also fuels technological innovation. Each mission to Venus challenges us to develop new technologies and techniques to withstand its harsh conditions. These advancements not only aid our exploration of Venus, but also have potential applications here on Earth. So, you see, despite its inhospitable environment, Venus remains a treasure trove of scientific opportunities. Its study could unlock secrets about our own planet and potentially even life beyond Earth. As we continue to explore Venus, we inch closer to answering some of the most profound questions about our universe. From ancient observations to modern missions, Venus continues to captivate us. This celestial body, often referred to as Earth's twin, has intrigued astronomers and space enthusiasts alike for centuries. We've journeyed from Galileo's first telescope observation in the 17th century to the Soviet Union's Venera 1 mission in 1961, charting an exciting course of exploration and discovery. Venus's unique characteristics, from its carbon dioxide-rich atmosphere to its scorching surface temperatures, set it apart from our own planet. Yet, its similarities in size and mass to Earth have fueled our fascination and scientific inquiry. The current and future missions like the European Space Agency's Envision and the Russian Space Agency's Venera D promise further insights into this intriguing planet. The significance of Venus extends beyond mere curiosity. It offers us a unique lens through which to view our own planet and the broader cosmos. As we continue to unravel the mysteries of Venus, we come to appreciate not just our own planet, but the entire cosmos a little bit more.